Okay, so we're going to start with something we already know, which is this stuff. Anything that can be measured with a ruler, you can apply the proportionality to. So we've worked already with perimeters, but you can also use it for medians, angle bisectors, and altitudes if you know the triangles are similar. If you don't know the triangles are similar, you can't do it. So little practice there, find x. We'll be back to about getting out your calculators, because you're going to need them.
That's a weird color.
Yes or no?
Yeah.
Golf clap. Okay, a couple questions for you, Drew.
Yeah.
What kind of thing is MK? Monkey, kangaroo.
Medium.
It's a median. How do you know that?
Because it goes from the opposite vertex and it bisects the opposite side.
How do you know that?
Because those two little tick marks.
Okay. We know that the big triangles are similar because it tells us that in directions. And since the medians are something that can be measured with a ruler, then we get that proportion. You didn't have to necessarily set it up the exact same way he did. He did median over median equals side over side. You could have done median over side equals median over side. A lot of different combinations. And cross multiply, get 7.5. Any problems? Good. Here's our one theorem for the day. It is called the angle bisector theorem. That's a blank screen. There we go. So I took a triangle and I drew in the angle bisector. How do I know that's the angle bisector? Because I got these two little tick marks down here that shows you that the angles are the same. So the black segment is the angle bisector. That angle bisector splits the other side into two parts. I labeled them A and C. A and C are not always congruent. In fact, they are seldomly congruent. As a side note, what kind of triangle does that need to be in order for A to be equal to C? Avery.
Isosceles.
Or equilateral. If it's isosceles and this is the vertex angle, they will be equal. That doesn't happen very often, so don't dwell on it. When we have that scenario, angle bisector drawn in hits the opposite side, we get this cute little theorem. This is all the fancy geometry speech. Who cares? You want the red. left chunk, so A is the left chunk over the left side, equals the right chunk over the right side. A over B equals C over D. And you're not always going to have an A and a B and a C and a D, so you want to remember it as left chunk over left side equals right chunk over right side. Then you get a simple proportion, then you solve the proportion, and everybody is happy through. Yes, Suzanne?
Can you explain why that works?
Why does that work?
Yeah.
Because the ratio set up between the chunk and the side is proportional for the triangle. So that angle bisector is going to split it into, splitting the opposite side into a proportional value comparable to the sides of the triangle. They're not similar triangles, they're not congruent, there's no relationship between the two halves that you get when you split it, except that that opposite side is split equally, or split proportionally. Let's look at some examples, shall we? Solve for x. We'll start with something fairly basic. Who else owes me a buck? Boy. Cops to it right away. Benny, question or answer? Question, go.
Okay, so for when you're using other scale factors,
Yes.
they can be switched around.
Yep.
However,
Yep.
can these ones be switched around?
Yep. You could do left side over left chunk equals right side over right chunk instead of left chunk over left side.
Yeah.
Could you do like left chunk over right chunk, left side over right chunk?
Yep, as long as you keep them in the right comparison. Okay. So, that having been said, we get what? Go ahead, Ben.
X over 15 equals 6 over 9.
Good. Cross multiply, what's x?
10.
Yes? We're happy?
Yep.
Okay, easy. Basic application of the angle bisector. We know that this is an angle bisector because, again, these angles are marked congruent, and you can see also that it doesn't split it equally because it's not an isosceles triangle. Easy, right?
Yeah.
Okay, let's try one a little more meaty. Solve for x.
We all use the same amount of paper.
That is kind of freaky that you all turn the page at the same time.
Yeah.
There's always a rebel in the group.
Has to be different.
Yep.
get the same one from our quiz. Except
Except different.
Well, you know what I mean.
So happy that's recorded now. Taunt you with it later. This is the same, but different.
So it's not the same. When I was 14 boxes, that was being recorded also.
I'll never touch that board.
Beautiful. Now I have a couple questions for you. Where did the 18 minus x come from, Amanda?
You have to subtract the x because it's not the whole length of the part.
Beautiful. So if we want to find this length st, that length st is the big length of 18 minus the x. Good. Common mistake that people make here is they would get 8x because for some reason they don't realize you got to add 6 to both sides. They want to subtract 6. Perfect. Any problems? Golf clap? Excellent. That's it. That's it. Like I said, one theorem today. That's all we got for you.
Oh, it's 14.
We are done. So let me stop this recording.